Hello, everybody, and welcome to Industry 4, the Digital Transformation webinar series. We'd like to welcome everybody today. This is the beginning of the 4-part webinar series and the Industry 4 and the Digital Transformation, where we hope to demystify some of the fourth industrial revolution and open up some real life case studies for Irish SMEs in Ireland who are already benefiting from the new technologies. So with that, I'd like to hand you over to Billy Schofield, who will take you through the next part of the webinar. Thank you.
Thank you, Paul. So what is Industry 4.0 and the digital transformation? My name is Billy Schofield, and I have worked in advanced manufacturing industries for the last 37 years. And I'm going to share with you today some of the things I have learned about Industry 4.0 and the digital transformation. So thanks to Paul and the SkillNet team for inviting me to talk with you today. And thank you for attending this webinar. So this is webinar 1 of a series of 4 running each Thursday, 1:30 p.m. Irish time for about 60 to 90 minutes. So the series is called Introduction to Industry 4.0 and the Digital Transformation. 4 webinars. Webinar 1 today, we'll be having a look at an introduction to Industry 4.0. What actually is Industry 4.0? We'll talk about 2 of the key concepts of the Industry 4.0 initiative. That's the smart factory and cyber physical systems. And we have a guest speaker today, Dr. Mahood Ali from IT Sligo. And Dr. Ali will be sharing us with some of the training that IT Sligo offer on industrial Internet of Things and Industry 4.0. And you'll have the opportunity to ask some questions of Dr. Ali later on in the program today. Webinar 2 next Thursday, we will be talking about decentralized decision making. Decentralized decision making is another core concept of Industry 4.0. In the Industry 4.0 setting, it's important to make decisions quickly. As we make more information and data available to the shop floor, to our technicians working on the shop floor, it's important that they're empowered to make decisions quickly. So we'll be talking about that particular area next week. Also next week on the agenda is cobots, collaborative robots. Cobots are robots that collaborate with their human operators to achieve a task. They're not locked behind some cage the way we used to see robots, but they're working in the same space as the human. And our guest speaker next week will be on augmented and virtual reality. So we'll find out what's happening with augmented and virtual reality, split the science fiction from the fact, and look at some real case studies happening here in Ireland on AR and VR. Webinar 3, we'll be talking about the hot topic of cybersecurity. You can't escape cybersecurity now, so we'll have a little talk about that. We'll be covering additive manufacturing, which is also known as 3D printing. That's about creating objects by adding material rather than carving and taking a material away. We'll talk about big data and data analytics. Then our guest speaker in webinar 3, and delighted to have this guy, Ian Keeney from Skellig AI, will be talking to us about artificial intelligence, what's happening with artificial intelligence, how it's been used in industry, and how it's changed over the last 20, 30 years from expert systems we were using back in the 80s to the advanced artificial intelligence we have today. and how that's become much more affordable and reachable for many companies. Webinar 4, the last of the 4 series, will look at future trends. What's happening in the future? What will things look like by 2030? And we'll start to build a roadmap for advancement. How do you build a roadmap on Industry 4.0 and the digital transformation? So we'll start you off with building your own roadmap about how you're going to introduce Industry 4.0 into your setting. Our guest speaker in webinar 4 will be Brian Cooney from KUKA Robotics. Really excited to have Brian. He's going to tell us all about those cobots and robots, what's happening in the world, how they're being used in industry, how they're being used in Ireland. So I'm really excited to have Brian here in webinar 4 to talk about robots and cobots. So a little bit about myself. My name is Billy Schofield. I'm a trainer. I have a master's in operations management from DCU, where I wrote my thesis on the readiness of Irish manufacturing companies for Industry 4.0 back in 2018. I have a BSc in applied physics from the University of Strathclyde, and I've spent 37 years working in industry. I worked for Motorola in Scotland when we were introducing the Six Sigma program back in the 80s, the first one that was ever rolled out. I spent 19 years working at Intel in Ireland and various managerial positions. And recently I worked for design and planning services in Ireland. I also worked as a senior process improvement advisor to the Royal College of Surgeons in Ireland. And I provide part-time lecturing to Dublin City University. So the agenda today will be going through our introduction. We'll be looking at Industry 4.0 and some of its origins and what it means. We'll talk about the key concepts of Industry 4.0. What are the key core concepts of Industry 4.0? And we'll have a look at how Industry 4.0 is being applied in Ireland. Then we'll have a chat with Dr. Ali, and I'll pose him some questions, and I'll open the chat box open to you guys to ask Dr. Ali some questions on Industry 4.0 and the industrial Internet of Things, which Dr. Ali is an expert on. So later on in the webinar today, we will be doing a little survey. It's just for fun, just to gather some little bit of data from our talk today. Completely voluntary. If you don't want to take part in it, you don't need to. It's completely anonymous, so no worries about any of the information being shared, your personal information. So completely voluntary. Just have, we're going to do it on Mentimeter. So have a tab open on your computer or on your phone at www.menti.com. And when the time comes, I will give you a code which will allow you to participate in the little data gathering survey. So www.menti.com, just open a tab there on your laptop or on your phone. So the first question I've got is, what is digital? We hear the term digital every day, but what is it? So maybe you could put what digital means to you into the chat box. I'm going to stop sharing here. Okay, so if you put it in, and what to do, Dara, if you could start calling out some of those items in the chat box for me. I'll just get yeah. And what I'm going to do is I'm going to capture them on my whiteboard. So Dara, you maybe can call out what do people think? What does digital mean to them? And we'll write it here down our whiteboard.
Well, Billy, I think the first one here is very accurate. It's not analog.
Not analog, that's a good one. Yep, going to get that one. What else?
We have electronic processes.
Electronic processes, yep, that's a great one. Yep.
We have data captured as digital format.
Yep, data in a digital format.
Readable data.
Readable data.
Discrete data.
Discrete data, yep.
Binary.
Binary.
Automated processes.
Automated processes, that's great. So that's quite a list we've got there. I'll just review that a second. I know it's just a sample of what's going into the chat box. So we're saying digital is not analog, it's electronic, it's digital data, it's readable data, discrete data, binary, and automated processes. So there are some great inputs on what actually we mean when we say digital. So over the next few slides, we'll explore what digital actually is. So Industry 4.0 origins. What are the origins of Industry 4.0? So Industry 4.0 is the fourth industrial revolution. When people refer to Industry 4.0, they mean the fourth industrial revolution. The expression used for this fourth industrial revolution is Industry 4.0, a phase that's based on software revision labeling. So I remember, it's just like when you had different versions of software, DOS 1.2, DOS 2.0, 2.3.0. People have just applied that name to the fourth industrial revolution, and we refer to it as Industry 4.0.
Excuse me, Billy, it is presenter view. Maybe you can just put it on slide mode, yeah.
What's wrong? Oh, I've got it on presenter view, okay, sorry.
Yeah, so yeah.
Okay, apologies. Technology, eh? Okay, I'm just going to share my screen again and screen 2. Okay, how's that? Is that better?
Perfect.
Okay. Oops, I'm in the wrong slide, but technology. So the term Industry 4.0 was first used at in fact, the creation of Industry 4.0 was from the German Industry Science Research Alliance, and they instigated the Industry 4.0 program in 2011. And it was a program that was to bolster and improve the readiness of German manufacturing for the demands of the future. So it was born in Germany in 2011, created and funded by the German government specifically to try to improve the readiness of German manufacturing for future demands. Up till about 2014, the term Industry 4.0 was seldom heard outside of Germany. And the phrase Industry 4.0 was first used at the Hanover Trade Fair in 2011. In America, a concept very similar to Industry 4.0 has been generated, and it's called the Industrial Internet, generated by General Electric. And I've put a link in here for people who want to find out more about the Industrial Internet on the www.iiconsortium.org. So it's a very similar concept to Industry 4.0. In America, it's called the Industrial Internet, run by the Industrial Internet Consortium. Industry 4.0 came out of Germany and is tended to what we refer to it in Europe. So what are the 4 industrial revolutions? Let's go back to our chat box and put in what are the 4 industrial revolutions? And I'll capture these on our whiteboard, and we'll have a summary of this at the end. So again, Dara, if you can capture what people are putting in for what are the 4 industrial revolutions in chat box.
So we have one, might be going back a bit far, but the invention of the wheel.
The wheel, yep, it's a mechanical system. Yeah, that's an interesting one, yep, goes back a while.
We have agriculture.
Agriculture, yep. Changed the way we live a couple of tens of thousands of years ago, the agricultural revolution beginning there in the way out there in the east of Europe, and it changed the whole of the world. Yep.
We have the invention of steel.
Steel, yep, inventing steel, yep, as a compound that we could use.
And Chris says digital.
Digital, yep, the digital industrial revolution is a real key one for us, especially what we're talking about today.
And we have the old classic, water and steam.
Water and steam, yeah. So they're great. So we've got some ideas here around what the industrial revolutions are. We put wheel, you know, the use of mechanics, agriculture, changing the way that human beings live, steel, new advanced compounds that we could use, digital, the use of computing in industry, and back to the very beginnings of the whole industrial revolution, the use of power through water and steam. So let's go back to share my screen, make sure I share the right screen this time. So I put this graph together to help describe what is classically, you know, we think of when we think of the 4 industrial revolutions. So I've put along the bottom axis the year from 1750 to the future, 2050, and I've plotted it against world GDP, world gross domestic product. So we have the first industrial revolution, which someone correctly identified, beginning in about the 1790s, and that was the use of power, mechanized power from water and steam, the power of falling water, driving mechanized factories, especially in fabric production. And we see those all over the landscape of the UK and Ireland. In fact, I'm sitting in Dublin today, and just up the road in North County Dublin is the town of Balbriggan, which became very famous for its first industrial revolution cotton mill, so famous that a pair of underpants were named after it. You know, you might have seen John Wayne in those Western movies wearing his Balbriggans. So the first industrial revolution begins in 1790s, water and steam, mostly in Europe, in the UK and Ireland, in fact. The second industrial revolution is recognized as the electrification of society and of industry. It begins in the 1870s with the building of electric power stations, initially in London in the 1870s. At that time as well, the idea of the process flow, the conveyor belt type flow starts getting introduced, especially in Cincinnati and Boston, where it's used to process meat processing. You've seen the carcasses hanging on hooks, moving through a production line. So that production line philosophy was being developed at that time as well. In fact, before that process, it would take a butcher a whole day's work to butcher a pig carcass. With the process flow technology that Cincinnati and Chicago founded, they could do a pig carcass in 35 minutes. Now, the electrification of rural Ireland didn't really begin until till 1946. We were quite late to getting electricity into some parts of Ireland. In fact, I was talking to a colleague last week who worked, his grandfather worked on that project, the electrification of Ireland, and William Rowe, in fact, the guy's name was, and he was telling us a story about how they went to Norway to source poles for to build the grid for the electrification of Ireland, and they met with the Norwegian government and said, and they were saying, how many poles do you need? How many do you need? We said, we'll take the lot, we'll take the whole forest, 1 million poles transported back to Ireland. Now, the third industrial revolution is just quite rightly identified as the digital revolution. It begins in about the 1960s when we start to see sophisticated integrated circuits becoming available and allowing for sophisticated control systems in industry. So we refer to that also as the digital revolution. Those microprocessors are being produced by companies like National Semiconductor, Texas Instruments, Motorola, and Intel. And an integrated circuit contains thousands, and in fact today billions of transistors, and all a transistor is a switch. It has two states, it's either off or on, and we refer to that as 1 or 0, hence the term digital. And through a form of mathematics called Boolean algebra, we can do computing on those ones and zeros. All those billions of transistors switching off and on allows us to do computing on it. And in fact, computing Boolean algebra was founded here in Ireland in University of Cork in 1870 by George Boole, who founded that type of algebra named after him. So in many ways, you could think that the digital revolution begins here in Ireland in the 1870s. And of course, the fourth industrial revolution, we spoke about it, the idea of the fourth industrial revolution being promoted in Germany in 2011. And really at its very core was using internet technologies in a factory setting. How do you use internet technologies to gather information and data and share it through your network within the factory? So to help us, I mean, obviously creating GDP is one great thing, but there are other advantages of the industrial revolutions. And I've plotted this one, we've put GDP on in the orange, and I've put life expectancy on in the green. And all industrial revolutions are is a scientific advancement. It's taking the advancement of scientific knowledge and applying it to industry in a very intense way. So we've seen that the first industrial revolution in the 1870s. At that time, life expectancy was only about 28. By the time of the second industrial revolution, life expectancy on the planet had risen to 30. And by the time of the third industrial revolution in the 1960s, life expectancy on the planet is about 55. And by the time of the fourth industrial revolution begins, life expectancy is 70. And in fact, in some very advanced countries with very high GDPs like Ireland, I mean, life expectancy for males and females as well into their 80s. So the industrial revolutions and scientific advancements have helped us increase world GDP hugely. And along with it, huge benefits to humanity. So just one other question for you, the chat box is, what are the other impacts of the industrial revolutions? So we've seen the industrial revolutions have allowed us to increase GDP, have allowed us to increase life expectancy on the planet through scientific advancement. What other impacts have we seen from the industrial revolutions? So just put them into chat box. And I'll capture them on our whiteboard again. So Dara, if you call out some of the impacts of the industrial revolutions for me.
Yeah, absolutely. So first off, most importantly, some would say, our jobs.
Jobs, yeah. Which ties in closely with the GDP, you know, as we see gross domestic product increasing, you know, employment increases.
Absolutely. And we have education and healthcare, which I suppose are directly linked to jobs.
Education and healthcare. Any other impacts from the industrial revolutions?
Sean says climate change.
Yeah, climate change, huge problem for us, the biggest challenge that society has today.
We have consumer choice, increased consumer choice.
Yeah, that's a fantastic one. That's something that, you know, Industry 4.0 has really enabled as bespoke selection of products, making a product, you know, bespoke for a specific customer. So internet technologies have enabled that for factories and companies to produce that.
And an interesting one, globalization.
Yeah, globalization. Yep, it's unbelievable. Yep. I'm sure there are people from many different countries on this one meeting today. You know, if I'd been doing this 10 years ago, I'd have been sitting in a office in Dublin somewhere talking to a bunch of people from Dublin. So globalization and the whole world becoming one market is a huge change that the industrial revolutions have pushed. Any others?
We have higher levels of productivity without the labor intensity.
Yeah, productivity. So more producing more with less, you know, that which is great. You know, we're getting much more efficient. Okay, they're great examples of some of the impacts here. And I jotted some down for myself this morning and put a few charts together to try to understand what the impacts of the industrial revolutions have been. So I'm going to try to share my screen again correctly. So we're talking about the impacts of those industrial revolutions. So one is the population of the world has hugely increased through that time. If we go back to 1800, there was only 1 billion people on the planet then. Today, there are 8 billion, and it's expected to stabilize and plateau at 11 billion by the end of the century. Our consumption of fossil fuels has hugely increased through the industrial revolutions. You know, our use of coal, oil, and gas. And you know what? It's not going down. We're all talking about it, but we're still using these fuels in huge quantities on the planet, and it's not going down. And then as a consequence of that, and some of you mentioned this, is that it's driving problems for the environment and for us all ultimately. The amount of carbon dioxide released from those burning those fossil fuels into the atmosphere has been exponentially increased through the industrial revolutions, creating a greenhouse gas effect. And of course, the consequence of that, and someone got it spot on, was that it's caused the temperature of the planet to increase. So the temperature of the planet has hugely increased through these industrial revolutions. So we're seeing impacts, both positive and negative, from the 4 industrial revolutions. So I'd like to talk now about some of the key concepts of the 4th industrial revolution, Industry 4.0. So the fundamental key concept of Industry 4.0 is the smart or connected factory. We'll be talking about that a little in a few minutes. The second fundamental concept is cyber physical systems. These are systems where software and computer algorithms control a physical entity, usually in a factory, but now, in fact, in many of our homes. The third key concept of Industry 4.0 is decentralized self-organization. And in the Industry 4.0 setting, as we get more data, more information, and make it available to the technicians working on the factory floor, we need to enable better and quicker decision makings. And that's what decentralized self-organization is about empowering people who have the information and data to make the decisions. And lastly, the fourth key concept of Industry 4.0 is cobots, collaborative robots, robots that collaborate with their human operators to achieve tasks. So today we'll be talking about the smart factory and cyber physical systems. In webinar 2, we'll talk about decentralized self-organization and cobots. So the industrial revolution, the fourth industrial revolution began 2011, and we've seen the smart factory, cyber physical systems, decentralized decision-making, cobots, and all this is about pushing productivity and efficiency. That's what it's all about being more productive and being more efficient, consuming less resources to achieve something. And that's very tied in with the philosophy that many of us use of lean in our factories and of our sustainability programs about using less resources. So in many ways, Industry 4.0, lean and sustainability are all overlapping concepts. 3D printing, artificial intelligence, autonomous systems are becoming hugely common, especially who would have thought we'd see autonomous systems in cars. Our cars are slowly becoming more and more autonomous as each year goes by. And we're on the advent of mass quantum computing becoming available to us. And a quantum computer is a new type of computer. You won't ever own one because they have to be kept at very low temperatures, near to 0 Kelvin. And a quantum computer doesn't work off those ones and zeros of the transistors we spoke about, you know, the ons and offs, the digital mathematics that we apply to it. But the quantum computers can have many, many different states. So they allow for much more complex computing. And we're on the verge of quantum computing now. You won't ever own one, but you'll certainly be using a one on the cloud in the very near future if you're not already accessing one. So Industry 4.0 is nothing new. It's 10 years old now. 2011, the concept was first spoken about. So the digital transformation never stops. We're continually seeing advances in technology, advances in science, which are being applied to industry to drive the digital transformation. So key concept one was the smart or connected factory. This is fundamental to the Industry 4.0 program, the initiative. So the smart factory is a manufacturing facility that harvests data from equipment sensors to enable self-directed systems. This data needs to be transferred from the manufacturing equipment sensors to a centralized information technology database for analysis and monitoring. So that's quite a nice definition, I think, of the smart factory. And I remember when I started working in industry in 1984, I remember working in factories and having to crawl into really inaccessible places, crawl to this pump, get all this data off the pump in quite a hazard environment. I'd have to go through, write down the temperature of the pump oil, the color of the pump oil, the current the pump was pulling, the nitrogen ballast flow into the pump. I would then crawl back out, get out of the factory floor, back up to the office. I'd put that data onto paper charts, then decide, well, what am I going to do? Am I going to get the pump oil changed? Am I going to get the nitrogen ballast adjusted? I then have to make a decision. In the smart factory, that's all different. The smart factory, the sensors on the pump can gather the information, it can transmit that information through the internet directly into our IT database, where we can then apply statistical process control. We can automatically apply artificial intelligence. We can make decisions. We can have the pump current or the pump nitrogen balance automatically adjusted on the pump and not have to crawl back in and adjust the pump. So that's the power of the smart factory, gathering data from the equipment on our shop floor and having it transmitted into our IT databases and applying statistical process control, artificial intelligence to it so that systems can be adjusted and optimized real time. So the smart or connected factory. So the smart or connected factory is a manufacturing facility equipped with autonomous systems using data from sensors. That's a key point, having sensors on your equipment to monitor the equipment. So machines, sensors, and people sharing information through the internet of things. That's what the things are, all these sensors, people, machines on the internet, sharing that data in our smart factory. And I've put a link in here and I'll share some of these slides with you at the end. And this one from Science Direct. It's a great read on a summary of what the smart factory is. And it's a literature review, and literature reviews are great because somebody's went to the time of reading, you know, hundreds of papers at a time and summarize them for you. So you can get a real good insight into the latest thinking on the smart factory by reading this one paper. So it's, if you're going to read one thing on the smart factory, I would recommend this paper. So the smart factory. So in the smart factory, we have our machines on our shop floor, and the factory machines that we use to produce our goods. Some people refer to this in the smart factory as the things layer or the perception layer. That's just a little bit of terminology that people you might come across from sometimes. Then that information has to be shared through to our IT systems. And a common way of doing it is using open platform communications united architecture. It's just an open architecture that anybody can use and can apply it to their equipment to transfer information. And it's great because it means that multiple vendors can use the same communication architecture. And in fact, if you're thinking about introducing a smart factory into your smart factory concept into your facility, you should talk to your vendors, your equipment vendors. You know, what are they doing? Are they offering smart factory solutions? Is old equipment retrofittable? Can the sensors be changed on it to allow it to communicate information? Now, this information is usually stored in an intermediate area called the asset administration shell, and some people refer to this as the abstract layer, and that's before we transfer the data into our IT system. So it's like a digital summary of our factory equipment. I made a mistake. I've done a presentation recently, and every single slide, instead of writing AAS, I wrote ASS. That's a deadly mistake. Just watch out for that one. The difference between AAS and ASS is significant. So we can get the data into our IT systems, and up here we have what our applications layer sitting in our IT systems. So our applications could control, we have our statistical process control charts. We can apply artificial intelligence to the data we're collecting. We can store the data, we can share the data, and we can build you know, summaries, dashboards explaining the data to help us with our decision making and sharing it with other people. So that's what the smart factory can do for us. We can gather the data, transfer that information from sensors into our IT database to make decisions from it. Now, something I've seen happening recently has been some trend from the communication companies, you know, like Vodafone and such, of supplying local 5G networks to factories, so that you could have in your factory a local 5G network where you allow this transfer of information to actually happen wirelessly. Then one other thing I'd like to mention on that is edge. You might have heard of edge computing. So edge computing is about bringing that computing power sometimes closer to the factory machine. You instead of all the data processing happening up here in the applications IT layer, you can have some local computing power at your factory machine, and you might do that for security reasons, cost reasons, or time reasons. If you know, in the example of an autonomous car, you may not want it to have to consult with an app in the cloud before it makes a decision on what it should do if it sees an obstacle. You want that computing power to be close to the vehicle, and when we do that, it's referred to as the edge computing. So just a little bit on open platform communication united architecture. That's the way that we can communicate that information from our sensors on our tools through to our IT database. It's open source, so that means it should be cheap, and it's highly flexible for us to use. So OPC UA communication allows for the communication of equipment sensors from databases. It's a machine-to-machine communication protocol in which devices ranges from sensors to program machines can be linked together over a single communication loop. And then we spoke about the RAMI, the AAS, what it is, and you'll come across this as you delve into the smart factory. So the ASS is the interface between the equipment sensors and the outside world. That's what it represents. And I've put a link in there to some documentation on RAMI 4.0, which is the Reference Architecture Model Industry 4.0 Asset Administration Shell. So the second key concept of Industry 4.0 is the idea of cyber physical systems. So cyber physical systems are hardware, software systems that control and monitor physical processes. And cyber, the word cyber comes from the Greek to steer or to set direction. So the idea of a cyber is something that controls something that sets direction, something that's steering us forward. And cyber physical systems have actually become pretty omnipresent to us now, as the computing technology required for them has become cheaper and cheaper. 10 years ago, these were really only in the realm of the big multinationals who had the dollars to spend. But now we see cyber physical systems all over the place. You know, a cyber physical system can be something as simple as you controlling your garage door from an app on your phone. You're using some software, some algorithm to control your garage door. So they've been highly utilized within the automotive industry, within the aviation industry, within semiconductor industry, and within automation. So we've seen huge advances in the use of cyber physical systems in factories. 10 years ago, it was the realm of only the high-end multinationals. Now they're available to us all. And I've put another good link in there, which gives from Science Direct again, gives a great summary on cyber physical systems. And maybe I'll go back to my whiteboard, and maybe people give me some examples of cyber physical systems. So maybe put them into chat. Again, think of cyber physical systems that you see in your life, either in your factory or even in your homes. And I'll just take a note of them. Cyber physical systems. So Dara, if you can help me out here and read out some of the inputs we get.
Liam says it's another name for PLCs.
PLCs, yeah. Yep, that's a great one, yeah.
We have Alexa.
Of course, Alexa. I mean, Alexa's hugely changed things. You know, who'd have thought 10 years ago it was a thing of science fiction that we can control when our lights go off, when our lights go down, what our oven's coming on at, you know, from a device that we can speak to. So Alexa is a great example of a cyber physical system living in our homes.
Yeah, we have controllers as well.
Controllers, yeah, anywhere where we're controlling a physical entity, whether it's a valve, a door, you know, a temperature set point, using a software algorithm.
Building management, Billy?
Yeah, building management. So that's like BIM. Yeah, building management.
IPCs.
IPCs.
I think that's everything now.
Right, so they're all great examples of cyber physical systems. And cyber physical systems, again, just when we're using software and computer algorithms to control and adjust a physical thing in our factory or our homes. Right, and I'll go back to my slides and I'll try to get this right again. So I'd like to do the Mentimeter poll. So you should all have your tab open, www.menti.com. So if you don't have it, you can open a tab up if you want to take part in the survey. www.menti.com. So your instructions are: you have 100 points to spend. So you're going to spend them on this question. In your opinion, on what Industry 4.0 areas is your company focusing? And I've given you a selection to spend your 100 points on. And these are all common Industry 4.0 initiatives. So we're going to look at data analytics, digital twins, blockchain, connected products, the smart factory, cybersecurity, connected supply chain, decentralized decision-making, cobots, sustainability. I can't see that one now.
Do we need code for Menti?
I'm sorry?
Excuse me, do we need code for Menti? Code, passcode?
Yes, you will need a passcode, and I'll give it to you in a moment. So good question. Cloud computing, 3D printing, and augmented reality. Enterprise integration, or none of these, maybe you know what you're doing. So what you're going to do is you're going to decide how you're going to spend 100 points. If your company is only doing work on cobots, you might spend 100 points on cobots. If you're doing work on data analytics and cobots and sustainability, you might share your 100 points across those three. So share them across these items as you see fit in your opinion. So as Dr. Ali was asking me, do you need a code? Yes, so you're going to enter this code, 95176321. 95176321. In fact, Dara, if you could pop that code into chat so people have got it. And you'll get all the items that I spoke about there listed. And what to do is you can scroll down, spend your 100 points. Then at the very end, you can hit submit. When you scroll to the very bottom, you can hit submit. So you can scroll down, spend your 100 points, and then submit at the very bottom once you've scrolled all the way through all the options. So optional, anonymous, let's see what it gives you. So I'll give you a few minutes just to finish that. So I'll resume in 2 minutes time once you've had a time to look at that. So the time at the moment is 14:22. So I will resume with the poll results at 14:24. So you can maybe take a small comfort break if you need one. Okay, it looks like most of you got your voting in. So let me share what your results are. Okay, some votes still coming in there. Let's give it a minute to finish, then we can see what's the focus areas for the companies we've got represented today online, or the enterprises we have. So top item is data analytics. So huge amount of activity out there on working on focus on data analytics. And that's great information. I'll tell you, if you're a job seeker, you'd want to know that companies were looking at strengthening their data analytics. And important information for higher education institutes as well. Are they producing people with data analytics skills to help with these? The second item on our Pareto is the smart factory. So seen up there at number 2, people thinking about how can they get the smart factory into their enterprises? How can they move that data from the sensors on their equipment, on their shop floor, into their IT database seamlessly and automatically, and not doing what I was doing in the 80s and crawling about on my hands and knees and writing information down in my notebook. Then, and maybe not surprising to see, number 3 coming in here is cybersecurity. So really number 3 there, cybersecurity. And that reflects a lot of the concerns that we've seen, especially this year with with the massive hack of our healthcare system here in Ireland, hugely impacting us all. And it just let us know how vulnerable we can be to someone hacking our information, or somebody stealing our intellectual property. So cybersecurity is number 3 there. So interesting top 3: data analytics, smart factory, and cybersecurity. And I'll supply this Pareto to you at the end. Areas that I've got less focus are blockchain, the connected supply chain, and 3D printing. So let's have a look at some other groups. I'll just share again, and I'll go back to my PowerPoint. So coffee break's over. So let me think. So in 2018, I did do a survey with manufacturing companies through Ireland, quite a detailed survey. And at that time, data analytics was also number one. So it looks like we're exactly the same as what we polled in 2018. Connected factory, again, the smart factory, number two, same as we have today. Collaborative robots there was coming in at a number three, along with AI, additive, and enterprise integration. At number three, we had cybersecurity. You know, cybersecurity shot up with us all realizing how vulnerable our systems can be. So 2018, that's what companies were engaging in. Not too different to what you guys polled today at. I did note then there was a lack of focus on decentralized hierarchy and decision making, and we'll talk more about that next week. And in May 21, I polled another group, and they came out with a very similar Pareto as to what you guys came out with: data analytics, cybersecurity, sustainability. So it looks pretty uniform about what's happening across Irish manufacturing and Irish industry just now. People are thinking about, how do I improve my data analytics? How do I use all this information and data better to my advantage? How do I improve the security of that information via cybersecurity? And how do I become a connected smart factory? How do I move that information on sensors into my IT database so I can gain the benefits of it? So as we spoke about the industrial revolution, the fourth industrial revolution has been running since 2011. We have new things coming. We spoke about quantum computing coming, and we'll talk about that in webinar 4. The whole idea of wearables as well is changing things, where we can put sensors on people and record information from those for health reasons, and in the workplace as well, to gain information that helps us to be more productive and efficient. Coming this decade, there'll certainly be 6G technology, allowing for quicker wireless communication. And then at the end of this decade, we'll start to see something in the terms of neurotechnology. So a lot happening in the future, and we'll be talking about the future in webinar 4. So I like to think about the Industry 4.0 as a factory. This is my Industry 4.0 factory. So at the base of the factory is the smart or connected factory, an area that many of you are focusing in on just now. On the pillars of the factory are cobots, collaborative robots, which we'll do a deep dive into in webinar 4. Then we have cyber physical systems, and we spoke about cyber physical systems having software and algorithms control physical things in our factories. Then at the pillar, at the roof over everything, there's going to be decision makings. How do we empower employees to make decisions quicker as all this information and data is available to them, and get away from a very hierarchical decision making that we still see in some of our factories? So within the Industry 4.0 factory, we have many tools, and we'll be talking about those tools over the next 3 webinars. Digital twins, which is a simulation of a real physical object, creating a digital twin of it from live data gathered from the physical object. Augmented reality and virtual reality we'll be talking about next week. Cybersecurity we'll be talking about in webinar 3, and you know, it's a huge interest out there. We've seen it was number 3 in our Pareto today. 3D printing, we'll be talking about that. It's always been closely aligned with the Industry 4.0 initiative, although in our Pareto today, we can see it's relatively low down the interest level at the moment. Data analytics, top there, number 1, how do we improve our ability to use this information and data? And that's a great place to start. Improving our data analytics capabilities, I think, is a fantastic place to start. And then artificial intelligence and webinar 3, we'll do a deep dive into artificial intelligence with Skellig AI and the team there. So I would like to introduce to you today our guest speaker, Dr. Mahood Ali. Dr. Ali holds a doctorate in photonic engineering and has taught undergraduate and postgraduate courses. He's published almost 60 peer-reviewed articles on subjects such as the industrial Internet of Things, smart manufacturing, and laser welding. Oh, there's a lot of demand for laser welding in Ireland at the moment. Welcome, Dr. Ali.
Thank you so much, William, for introducing me with the audience, and I'm really thankful to the audience that they have joined us today in today's session. So can you hear me?
Yeah, we can hear you loud and clear, all the way from Limerick, I think.
Nice. Yeah, that's nice. So currently I'm working in Institute of Technology Sligo on specific project that is related to the laser welding of polymers. So that is also industry-based project. And my background is photonic engineering and my basic degree is in electronic engineering. So I know how to actually connect and how these technologies are evolving day by day. And the future is like photonics and also industrial revolution, Industry 4.0, as you have already discussed. So today I will introduce about the courses that we are actually offering in Institute of Technology. That is, can we go towards next slide? Okay, I think these slides are okay. So we're discussing about the courses that we are actually offering here in the Institute of Technology Sligo. That is Internet of Things, Fundamental of Internet of Things, and the other one is Industry 4.0. Yeah, Introduction to Industry 4.0, and the second course is Industry Introduction to Fundamental of Internet of Things. So please, next slide. So before going towards the course outlines of Industry 4.0, I just wanted to introduce about the industry revolutions as discussed by Billy about these revolutions. So we can see there are many emerging technologies during Industry 4.0, and it is the result of the previous revolutions, from first revolution to towards the third, fourth revolution. And there are many enabling technologies, key enabling technologies towards Industry 4.0, and one of them is actually electronics and digitalization, as discussed by Billy. And as it has been discussed earlier, that there is a quantum computing, and that has been derived from photonics, and you will see in the future that photonics will be everywhere, and photonics will be the key enabling part of the Industry 4.0. Because of the data and speed handling issues, so photonics is one of the best solution for this problem. So please, next slide. So in Industry 4.0 technologies, we can see here that from front-end technologies that are actually can be seen as a part of the Industry 4.0, smart supply chain, smart working, smart manufacturing, smart product, and also towards the market. And all these are actually connected with the basic technologies. Those are called Internet of Things, cloud, data cloud, and also big data and analytics. So all these things are actually interconnected with each other for enabling Industry 4.0 technologies. Next, please. So in the course Introduction to Industry 4.0, we will be covering in introduction, brief introduction, and also historical review and enabling technologies. What are the enabling technologies in Industry 4.0? For example, as I have said that digitalization, automation, and also electronics, photonics, and all these emerging sciences and technologies, all these are actually the enabling technologies, and especially internet. And next is actually cyber physical systems, smart manufacturing, artificial intelligence, how can we interrelate with the Industry 4.0, and then how can we actually use all this data with the help of the cloud computing. And we will be discussing in the course that is actually case studies from different industries, and how can we interrelate with our existing scenario and industry, and what are the opportunities and what are the basic challenges right now we are facing in Industry 4.0 to implement this revolution. So all these things will be covered in this course, Introduction to Industry 4.0. Next, please. So the second course that has been actually offered through the Institute of Technology Sligo is Fundamentals of Internet of Things. So in Fundamental of Internet of Things, we will discuss all about the things that are interconnected with the internet, and how can we take this the data from the things, and how can we make it efficient and useful for our own applications. All these things will be discussed in this course. Next slide, please. So the applications, if we think about the Internet of Things, so we can think about different applications. For example, if we want to automate our home, so we can connect different types of sensors and different types of devices with the help of the internet, and then we can control through the internet. So this is how actually it can be enabled, and also it can be introduced in smart infrastructure in homes, and security or surveillance, and healthcare, transportation, industrial, retail, and other applications. Whatever you think, the Internet of Things will be there. So this is how actually it will be introduced, and we can see that the future is very smart with the help of the Internet of Things. Next, yeah. So the course offered by the Institute of Technology Sligo for Fundamentals of Internet of Things will be comprised with these outlines: introduction to Internet of Things, enabling technologies. Likewise, in the Industry 4.0, here are also some enabling technologies for Internet of Things. And what is the basic Internet of Things architecture? Of course, there is a not specific or basic architecture. So there are many different schemes of architectures that will be discussed in this course. And then the key part of this Internet of Things is sensors and circuits and the embedded system that are actually used for the realizing the Internet of Things. So these will be discussed, and also the actuators. And next thing will be actually discussed: connectivity, networking, and what are the issues on these things that will also be discussed in this course. And Internet of Things and edge computing is also related. How we can use this edge computing for the purpose of the Internet of Things. So this will also be discussed in this course. And what are the basic security issues, and how can we resolve through the Internet of Things, and what are the security of the Internet of Things. So all these issues will also be discussed in this course. And also similar to the Industry 4.0, we will also discuss about some case studies and various industries in this course, and what will be the opportunities and challenges, and specifically how can we interrelate the existing 5G technology and artificial intelligence with the Internet of Things, and what will be the future of the Internet of Things. How can we actually use these things in future? So all these things will be discussed in this course. Yeah.
So that's great, Dr. Ali. Dr. Ali, so how can people find out details about these courses? Where can they get details on them? Is it on your website?
Yes. Basic courses outlines can be found through the SkillNet website. There are outlines over there, and if someone wants the details of this course, please contact with Paul, and we will actually provide the outlines and all the details of these courses. Yeah.
Yeah, and I can say I was recently on the Internet of Things class by Dr. Ali, and what an amazing day that was. A real immersive day in the Internet of Things. I learned so much that day. So it's a real deep dive into the Internet of Things, much more detail than we'll be covering in these webinar series. So if you want to do a deep dive, book your time with IT Sligo team and Dr. Ali. So, Dr. Ali, I was chatting to some colleagues this morning, and they were asking me a few questions about the Internet of Things, and I said I would ask them the questions on their behalf. So, Dr. Ali, the first question I was given was, explain what the Internet of Things is. Can you define what the Internet of Things is?
Surprisingly, the answer is not straightforward, because the Internet of Things have different types of definitions, because it's the evolving technology, so that so far we don't have any fixed definition for this Internet of Things. But of course, there are some platforms, they have defined this Internet of Things. For example, IEEE, international organization that is actually engineers, International Electrical and Electronic Engineering Association. So IEEE gave the definition about Internet of Things, such as a network of items, each embedded with sensors which are connected to the internet, is called Internet of Things. So it relates to the physical aspects of the IoT only. Internet of Things also address other aspects that cover many areas, such as enabling technologies, software, application, services, business models, social impact. On the other hand, there is another standard that is called International Telecommunication Union. They have also given some standard definition, and that is in fact global infrastructure of the information society, enabling advanced services by interconnecting things based on existing and evolving interoperable information and communication technologies. So it means the interconnection of things that can be physical interconnection or virtual interconnection that can also be done through Internet of Things. And there's another common definition through European Commission, which is actually the IoT is the internet, is the network of physical objects that contain embedded technology to communicate and sense or interact with their internal states or external environment. So I think this is the more common definition, and it covers all the things like physical, virtual, both, and also the things. So I think I will prefer the definition of European Commission for Internet of Things. Yeah.
Yeah, fascinating. So, what? Here's another one for you that was given this morning. What is a thing, Dr. Ali? What is a thing?
Yeah. So if you think about the thing, means what is the thing? Thing is actually in IoT world, the thing is always equipped with some electronic element. So it means that should have some sort of like identification. It is like any object that have a name that is called thing. So in case of IoT world, so the electronic equipped with the electronic element which actually give the name through the RFID tag or active sensor sensing data, or to the global network, or any autonomous device that can react or on environmental changes. So that is called in fact thing.
Okay. And you mentioned sensors earlier on. What's your definition of a sensor?
Sensor is in fact the device that can actually take the data from the ambient environment or any environment to make it to give the Internet of Things to the network and for the analysis and to make it more useful. So that we can take the information from that sensing data, and after that we can take other action for making the system, or means the process, more optimized.
Yeah. Okay. Yeah. And lastly, maybe Dr. Ali, could you describe some of the settings where the Internet of Things can be useful in industry?
Yeah, sure, for sure. Yeah, there are many scenarios we can see in the industries. This Internet of Things can be used. Those are, for example, in the industry, autonomous industries, as you have discussed about the things like autonomous vehicles, and they took the data, they take the data and send towards the cloud, and there's some sort of like the other algorithms, machine learning, artificial intelligence, and so they analyze the data and give us the feedback towards the to making the autonomous vehicles more efficient. And similar in the industries, in industries, we can also see that the other examples, for example, the agricultural industries or healthcare side, or even in the manufacturing side. So all the machineries are equipped with some sensors, and we can collect those data from the sensors and process, and after that we can make our system or machinery more intelligent on the basis of that sensing data with the help of the analysis and processing of the data.
Okay. I'd like to invite Paul in here. Paul, do you have any questions for Dr. Ali?
Hello, I'm just coming in.
Hello.
Ali, I'd like to thank Billy and Mood on some great presentation and lots of interesting features.
So Paul, I've still got a little bit to do. I was just wondering if you had any questions you would like to ask of Dr. Ali on the Internet of Things at this time.
I think a lot of my questions have been answered.
Okay,
already.
brilliant. So maybe if anybody's got questions, you could pop them into chat. And Dara, maybe you could pick out one or two questions. We're approaching 10 to, so maybe pick out one or two questions and pose them to Dr. Ali and myself from the chat box. So if anybody's got questions, stick it in chat now.
There's nothing up yet now, I'm afraid. I think you answered all the good ones, Billy.
Okay, that's fine then. That's great. That's great. That means we've done a good job. So industry
How to
4.
establish a business case for adopting IoT is just coming up there. Will 3D printing become more important in the future?
Okay, we'll take two.
First, we will take the first question, that is actually how to establish a business case for adopting Internet of Things. So there are different types of scenarios. So means what type of business are you looking for, and how can actually you can establish that business on the basis of the Internet of Things. It can be like some sort of like hardware side or software side. So it actually can interconnect with different platforms, so like such as like big data, and also big data can be actually enabled through with the help of the Google or Amazon, or means there are many different types of systems that can help us to handle this data and analyze the things. So we can start up with some type of means sensors, or it totally depends upon the nature of your business and nature of your work, and whatever you think, you can consult with the IoT expert, and they can give you the solution that how can you actually solve with the help of the Internet of Things.
Okay, that's good. I think we're approaching 10 to, so we probably don't have time for many more questions. What we can do, Dara, is we can take a note of what's in the chat box, and we maybe come back to them at our webinars 2, 3, and 4.
Yeah.
So what we spoke about today, we spoke about the 4 industrial revolutions. So you probably knew what they were already, but we explored them today. The mechanical revolution in the 1790s, the introduction of electricity into society, the digital revolution in the 60s, driven by the semiconductor industry and the creation of integrated circuits. Now we are in the 4th industrial revolution, the using internet technologies in our factories to move data about and make decisions. We spoke about the origins of Industry 4.0, how the program started in Germany in 2011 to try to improve the readiness of German manufacturing for future demands. And we've seen that there was a similar program in America called the IIoT, founded by General Electric. We spoke about key concept 1, the smart factory, and it was great to see that many of you out there are thinking about smart factory and how you adopt that in your setting. I think it was number 2 in our Pareto when we polled you. We spoke about concept number 2, cyber physical systems, physical entities being controlled by computer software and algorithms. That's what that's what entails a cyber physical system in our factory. And next week we'll talk a little bit about decentralized decision making, about making those decisions quicker. I like to think of this part as the people part of Industry 4.0. Then cobots, key concept 4, I'll touch on it next week, collaborative robots, but we'll do a deep dive in webinar 4 when KUKA Cobotics join us, and we can have a real look at what's happening in the world of cobots and collab and automated robots. So we covered quite a bit today, and we found out what's happening with Industry 4.0 in the network who joined the meeting today. And I'll send out that Pareto and our whiteboard work that we done today, and the links that I mentioned earlier. So I've got a call to action for you. So this is your homework for next week. So assess your organization for its adoption of smart factory and CPS systems. Have a look around. Have you got any examples of a smart factory and a cyber physical systems in your setting, in your factory, in your enterprise today? So to start to think about it, do you have examples? And you probably do. So go and look and search for examples of smart factory and CPS systems in your existing facility today. So list them down, detail them. Where are they? What are you using them for? Then start to think, are there high cost areas in your organization where the smart factory and CPS could be applied? You don't need to throw it at your whole organization. Go to high cost areas and say, can the smart factory, can cyber physical systems help us in these high cost areas to be more productive and to be more efficient? Then benchmark yourself. Find out what your competitor's doing. You know, you'll have a competitor who you admire and you think is doing a great job, and they're potentially going to take your business one day, and you worry about that. Go and find out what they're doing. Find out, what are they doing about smart factory? What are they doing about CPS? Do they have a program? What equipment are they installing in their factory? What type of upgrades are they making? Try to find out, try to benchmark yourself against the competition as you start to think about the areas where you want to focus in for a smart factory and CPS in your facility. So I'm going to close with a quote from Deloitte Consulting, who said, "The fourth industrial revolution is still in its emerging state, but with the swift pace of change and disruption to business society, the time to join is now." So this is a 4-module course. Next week, Thursday, at 1:30 p.m. Irish time, we'll be looking at decentralized decision-making, cobots, digital twins, and we'll be doing we have our AR guest speaker next week. So that's going to be a great session with some experts available for us to chat to about VR and AR, augmented reality and virtual reality. So we've done some work on the whiteboard today. I'll take a copy of that and I'll share it with you all so you can see what our answers were to some of those questions I posed, which were, what were the 4 industrial revolutions? What is digital? What have been the impacts of the industrial revolutions, and examples of cyber physical systems that you have seen out there in factories and in society?
That's great, Billy.
Well, so I'll just go quickly. Stay connected. You can visit my website on www.billyschofield.ie. Connect with me on LinkedIn, and you can email me at billyschofield.ie if you need further information. So that's all I have, Paul.
That's great, Billy. Thanks a lot to you and to Mahmood, and thanks for everyone for participating. So we'll be sending some information out. There'll be a feedback form if you can be good enough just to give us some feedback and see how we can improve for next week. But yeah, it's our first one, and hopefully we'll be even more seamless next week. So again, thank you, Dara, thank you, Mahmood and Billy, and hopefully we'll see you all again next week.
Okay, thank you. Yeah, looking forward to it already.
Thank you.
Here we go. Thank you. Bye bye.